Today we look at the maximum values, also minimum values. It's just what it sounds like it means. The highest values on a graph and the lowest values on the graph. When I say maximum or minimum values, we're talking about y values. That's a lot of writing. The values that we're talking about are y values. That's I said that just now. Definition: global maximum. That's the definition here. Global maximum. A global maximum value, remember, is a y value. Is also known as an absolute maximum. For a function to have a global maximum, there must be some x value. There must be some x value. Suppose there's a single x value. We'll call it c in this case. So there's some x value, say it's 2 or 4 or whatever. That's what my c will stand for. There's some x value so that when you plug it into your function, the y value that comes out, remember f of c is just the y value when you plug in c. So there must be some x value such as x equals c, some x value so that when you plug it into the function, it's larger than any other y value. Remember, f of x is just the y value. So when you plug in that x value, the y value that you get is larger than any other y value that you get from any other x value in the domain that we're working on. So if we're allowed to plug in all real numbers, then an absolute maximum or a global maximum is at the x value. It's at the x value. It is the y value if the y value is higher than any other y value when you plug in any other x that's not c. I don't know if that makes sense or not. You should rewind it and watch it again. Make sure it makes sense. If not, stop the video right now and ask me, because that's super, super important. So there has to be a largest y value for a single x in that domain. And it's similar for a minimum value, or a global minimum. It just has to be the lowest y value. So I'm just going to write that. It's a similar definition for an absolute minimum or a global minimum. So what are we looking for? Pretty much the highest point on the graph. So let me just draw something up real quick and we'll see. Just a quick example. Okay, so the domain here for this small example is any x value that's in between -9, including it, right, and 9, and not including that endpoint. So in this particular case, we do have a global maximum because we have the highest y value right here. The global maximum would be f of, if this is f of x, let's write that. So we have a global maximum at x equals -4. This is the c value from the definition. That's the c value because f of -4 is larger than any other f of x, any other y value, for all the x's in the interval -9 to 9. So that's why it's a global maximum. And the global maximum is actually, let's see, 1, 2, 3, 4, 5. Looks like 5. So the global maximum is 5. Don't get confused. Look at this. Look at what I'm saying. The global maximum at x equals -4. So it occurs when x equals -4. The actual global maximum is f of -4, which happens to be 5 in this case. Now, if we're looking for a global minimum, I mean, global minimums could be endpoints, but in this picture, there is no global minimum because the lowest point on the graph is just before you get to 9. But we're including everything right before 9. We don't actually ever get to 9. So this actually gets as close as you can to 9, but never gets to 9, never reaches it. So like, it also never reaches that y value of 8, -8. So like, the smallest y value that you can get is, well, I mean, there is no smallest because you can always approach -8, like -7.99. But you can always get closer, -7.99999. But you can still get closer than that. You can still get a smaller value. negative 7.999999999999999. But that could go on forever. You can get as close as you want to negative 8, but you can never reach it. And there's always a smaller value. You just increment in a smaller amount. So in this particular case, there is no global minimum. So that's the idea behind a global maximum or a global minimum, also known as absolute maximum or absolute minimum. So that's very, very, very important that you understand. The idea that we're talking about intervals is very, very important. So let's talk about relative maximum and relative minimum, or local instead of global. What? What is he talking about? I'll show you. So let's read this real quick and see if we can make it make sense. A function has a local or relative maximum at x equals c, which just means some x value, if the y value when you plug in c, remember that's what that means, the y value when you plug in c, or f of c, is larger, so that y value is the largest y value, is larger than any other y value for any other x, right? Because you're plugging in x's to get y values. So a function has a local maximum at some x value if at that x value you have the largest y value in some open interval that contains c. What the heck does that mean? It means if you can zoom in to any portion of the graph and there's a highest point, that's a local maximum. So if you can zoom in to any portion of the graph, that portion is the open interval that you would make up. If you can zoom into any portion of the graph and it has a highest point, then that point is a local maximum. All right, so let's. Was I recording? I don't know. Let's go back to our picture. If we take a look at this, there are actually 3 local maximums or minimums. So let's try and find them. First of all, this one right here, we know it's a global maximum, but it's also a local maximum, just because we can zoom in and pick off some piece where there's a highest point. It's that simple. And then here again, there's a local maximum. So at x equals maybe whatever that is, 7. At x equals 7, there's a local maximum again, because we can zoom in and there's a highest point. Similarly for local minimums, this is not a global minimum, but it is a local minimum because we can zoom in and there's a lowest point. That's all really that you need to know. So there's a local minimum here at x equals 2. So that's what that means. So let me just say real quick, it's a similar definition for local minimum. All right, I'm going to stop this and do an example in the next video.